we're going to look at Spring integration as a way of integrating otherwise disparate data sources and services. And Spring integration, of course, draws its inspiration from the amazing book by Bobby Hope and Gregor Wolf called Patterns of Enterprise Application Integration. And the whole point of the framework is to enable integration of otherwise disparate services and data sources, right? Data sources, okay? So it's all about making things that don't necessarily know how to talk to each other. And the easiest way to do this is to think about the world in terms of events, right? Or messages. So perhaps I want to observe files on a file system, and as soon as there's a new file, I want to publish an event and then respond to that, right? Or maybe I want to observe emails in an inbox, or maybe I want to observe new records added to a data source, a database, right? Or anything else. These things are all sorts of different, these all imply different APIs and different technologies. But with Spring integration, that the underlying details are hidden for you. So now you can think about it as just being a message that gets published, and there's an adapter that will publish the message for you, right? Obviously, you have to plug that in, but Spring integration comes with a whole toolbox full of integration adapters. And then once the message is published, you have the ability to then process that message, right? To take it and do interesting things with it. Perhaps you want to perpetuate it on and transform the payload or the metadata about that message called the headers. Maybe you want to split it up into numerous smaller messages. Maybe you want to selectively route the messages based on some sort of condition to another component. Maybe you want to do the opposite of splitting. Maybe you want to, in a downstream component, you want to aggregate the results of the split into one message and then perpetuate that message downstream. So you have lots of different things you can do with a message once you've seen it, once it's been published. And finally, when you have the message, you can then send it to a downstream component like an adapter or a gateway, right? So instead of adapting the data as it comes in, you can take the message and then adapt it to send it out, right? To send it out to something in the outside world. So maybe the genesis of the message processing flow came from a file in a file system, but maybe as a result of that processing, you'd like to upload something to an FTP server, right? Or maybe you want to send a message on an AMQP RabbitMQ broker, for example, right? These are all distinct possibilities, but by writing your code with Spring integration, you can use one component model and then compose stronger, more powerful solutions out of these smaller, singly focused sort of components. So let's take a look at that. Today we're going to actually go back to that alluded to example. We're going to build an integration that monitors a directory full of files and then takes the files and then processes them in some way and then uploads them to an FTP server. And I happen to have an FTP server here on my machine. So we're going to say files to files and what are we going to do? File monitor, files integration. Okay, so we're going to call that. And I'm going to bring in AMQP support. We'll bring that in here. We're going to bring in Spring integration, right? So there's the integration support here as well. We need I think that'll do actually. That should be enough for now. We're going to have to bring in some individual Spring integration modules for files and for FTP, but that should do us. So let's go ahead and hit generate, and we'll get a zip file. A zip file we can open up in our IDE, and it really doesn't, it doesn't matter which IDE as usual. So we're going to say files integration. What I want to do is I want to monitor a directory, and then if there's a new file in that directory, I want to take that file and I want to transform it in some way, and then I want to send the transformed data to a downstream system. In this case, an FTP server. So we're going to build an integration flow using the Spring integration Java configuration DSL. So we have that now because of Spring Boot 1.4. That's included in the Spring Boot starter integration dependency. So here it is right here. And I think the Java DSL is one of the coolest things that's ever happened to Spring integration. And I say that as a guy who's worked on Spring integration for many different years and talked about it for much of the last decade. I love Spring integration. So the DSL to me is a really big deal. And I don't think it gets enough time in the sun. So we're going to talk about it. We're going to build an application today in terms of that integration. So let's build our first integration. Okay. When I say what I'm going to do is I'm going to build an integration that looks for data in a directory. So we're going to build an integration flow. And we're going to call it files, right? And the directory, the directory full of information, I'll just call it the input directory, or I'll default to a hard-coded path here, my desktop in directory. We'll call that file in. Okay, so that'll be just a Java IO file, and I'll use a Spring property placeholder resolution to make that value real, and I'll use the DSL here. I'm going to say whenever there's a new record coming in from something, and in this case I need to provide an inbound adapter, right? That's the genesis of a messaging flow. I'm going to respond, I'm going to kick off this processing flow if there's a message that comes from this inbound adapter. So the inbound adapter is going to be the FTP adapter. So I need to bring in Spring Integration FTP. And there you can see there are a good many other modules here, and there, of course, there are many more besides that are in the open source world that aren't included in Spring Integration itself. So I'll say files dot inbound adapter, and what I want to do is I want to monitor the in directory. Very good. And I don't need to provide a comparator, so I'll leave it as is. And I'm going to specify a few things. I'm going to say that I want to auto-create the directory if it doesn't exist. Absolutely. I want to prevent duplicates. Fair enough. And that'll be, I think, that'd be enough. Now, what I want to do is I want to transform it. And we'll come back to what I'm going to do with this later. But for now, I'm going to create I'm going to tell it to use this transformer. And the contract for a transformer is actually pretty straightforward, right? It's a generic transformer. We're going to take the payload of type file in, and we're going to send a string out, and we must implement that contract. So there's this, right? And that actually can be a lambda, right? So that's a natural fit for lambda if we want. We just need to specify this, and then we can get rid of all of that, right? That gets much, much cleaner. Oops. Okay, and then I want to send it out. So I'll handle the result with an adapter, another adapter. And in this case, what I'm going to do is I'm going to send it to an FTP server, so outbound adapter. And I can't. This doesn't, it doesn't work quite like this. There's actually a very convenient interface that's expected here called a function that takes an adapter's object and a message handler spec. So if we just provide this lambda, we can then use the adapters method here to construct our flow here, and it's expecting a FTP session factory. Now, I happen to have, as I say, a FTP server running on my machine. So we'll just create a simple session factory here that works for FTP files. Okay, and it looks like I don't have the type on the class path for that. So let's bring in Spring Integration FTP. Very good. And FTP file. Well, I guess that'll be enough. Let me see. We want the default FTP session factory, right? So we'll save ourselves some pain there. We're going to say like this. And I'm going to set the port equal to 2121. The right thing to do here, by the way, is to use properties. So I should say, FTP dot port 2121 into port. I want a username, and I'll just provide some default values here. So the username will be JLong, the default rather, and I'll use a password. So I'll say ftp.password. Otherwise, the password will be Spring. There we go. And then we can just configure our FTP session factory with these defaults. So we'll say FTP session factory password equals PW, and we'll say ftp.set username equals username, and that I think will do. So we'll just return that as we've done it and as we've configured it. And now you can use the same code. You just need to provide properties via -d arguments or in the application.properties or something that start with ftp dot, etc. So we've done this. Now we just need to tell Spring to inject that bean here as a collaborating object. So we'll specify we want the FTP session factory, or the default FTP session factory here. There we go. And what's going to happen? What's going to happen is that we're going to run this adapter, and it's going to need to generate a file for us, right? It's gonna try and create the file for us, and so we need to give it a way to do that. And I'm gonna skip ahead here. I'm gonna go ahead and create a temporary. I'm gonna go ahead and create a remote directory. A remote directory. A file name. I'm looking for the implementation file name expression generator. File name generator. There we go. We're going to provide a new file name generator, and our file name generator is going to be based on the header. And so we're going to look at the incoming message, right? The Spring integration message. I'm going to extract from the message the header called the file name, right? So we want the file name here, and I'll extract this, and I'll return it as a value here, and I'll say that I want to get the value string file name equals string.class.cast. Oh, there we are. And I'll return file name dot. And what we're going to do here, my friends, is we're going to take the incoming files, which should be images, right? And in my case, I'm expecting images, and we're going to split the data. We're going to process the data and turn it into an ASCII art representation of that image. So it'll be a text file. So what I'm going to do is I'm going to split the incoming file name using a regular expression on the period right there, and then I'll say I want to use the first part of the name, and then I'll just rename it to .txt. Okay, so if it's a .jpg, then we'll if it's foo.jpg, well, then we should name it on the file system in the FTP server. We'll name it foo.txt instead. Okay. So there we are. This is I wonder if this is a good Lambda candidate. There we are. Yep, looks nice. So we can leave that. And we don't need this either. There we go. That's cleaner. So I think you'll agree that's not bad, right? We've got an adapter there, and we finally need to return the data. Now, we do have to handle this transformation, right? And this is actually something maybe you would do in a separate expression. Maybe you extract it out here and write the code separately. Heck, you could even put it in a separate class and then more properly unit test it. But for our purposes, it suffices just to do the code in place. So what we're going to do is we're going to take the data that's coming in, the file, and we're going to create an image banner. So I'm going to say that I want to create an image banner of it. This is a new feature in Spring 1.4. It's all the rage. It's certainly the most important thing that's ever happened to Spring, is the ability to turn images into ASCII artwork automatically. Thank you to community member Craig Burke. And then I'll bring in the source there. Okay, that's our image banner. And I'm going to write the image banner out. I'm going to print it out. So I need the environment there. I can see that that's a requirement. This is the Spring environment abstraction. So I'll inject that there. And I need also a class, and it doesn't really matter which one. It's just for class loading. And then I need a print stream, right? So I'm going to say print stream ps will equal new print stream. And I want, as with all things in I/O, I want this to be automatically closed at the end of the scope of its usage. So I'm going to wrap it in the auto-closable sort of block introduced in Java 7. My print stream needs a byte array output. It needs an output stream. So I'm going to create a byte array output stream like this. Okay, and whoops, byte array output stream. There we are. And I need to handle this exception that I've invited into my world here. So there we are. We'll say reflection utils dot rethrow method, rethrow runtime exception E. And now we'll pass that byte array output stream to our print stream, which will then pass to this, okay? And once that's done, I can say byte array output stream dot 2-byte array, and I'll create a string, banner text equals new string, like that, and we'll return the banner text that we've worked so hard on. So now we have our results. We can just inline it, I suppose. That's easy enough. And we're going to use that transformer here. So that's already been plugged in, right? It says transform. And mind you, I could have done all sorts of other things here as well, right? I showed you the transformation. I showed you how to do handles and so on. But I could split it. I could do a claim check. I could do I could enrich the data. I could filter it and resequence it and do custom routing to other kinds of flows and so on. But this is, I think, a very, very simple example of what we're trying to do. So let's go ahead and leave it as is, as we have it right now. Now, if this works, we should see the data. We should see any input JPG file automatically appear as a resulting file in the FTP server. So let's ensure that no matter what the nature of the file, that it only accepts that the flow only works for JPG files. So we're going to go ahead and further customize our pattern here, the thing that we're willing to accept. And so I suppose we could just try this. That might work. Let's see if that works. Okay, so it's probably an AND path expression. We can confirm as much by looking at this. And it says the pattern and new simple pattern file list filter. And the filter, it's an AND style path expression. So yeah, that should be fine, right? Just as AND style *.jpg. Okay, good. So now we have an integration flow that'll listen for data here, transform the incoming file using our file to string generic transformer, and then route the resulting string outside. Now the last thing that we need to do is we need to make sure that that header that has the file name in it is perpetuated. So instead of just sending a string, we're gonna send a message of string, right? This is the wrapper object that Spring Framework itself expects, and we will oblige, right? So I'm going to say message builder, and this is actually a Spring Framework ism. We're going to build a custom envelope object called a message. We're going to build it, but before we build it, we want to set a header. So we're going to set the header to be the file name itself, and the file name will be, of course, the incoming file source. So get absolute file dot get name. Okay, so there's that, and there we go. There's our simple flow. So that way, the downstream component, that is to say, our outbound FTP adapter, will be able to take the incoming file header and split it successfully, right? Otherwise, that header might not be there. So this is a good chance to look at how Spring, what's happening underneath the hood. Even though our components are written in terms of strings and files and so on, what's really happening is Spring is perpetuating message objects which have payloads, and that's why these components work, is because all these components really care about at the very lowest levels is they care about untyped, generic objects of type message, which have payloads and headers, which in turn are keys and values. So there's no reason that they shouldn't work together, right? They're meant to work together, even if the payloads and so on are different. And you can actually switch out the behavior by switching out the components upstream or downstream, right? So let's go ahead and see if this works, okay? That should be a very simple example, and this will be our Spring integration flow. Let me go to my desktop here. And I'll remove the input directory. And we see in the FTP's directory, in the FTP server, that I have nothing there yet right now. So I'm gonna, I'm gonna hopefully see .txt files once we've added images to the in directory. So let's go ahead and try this. We'll go ahead and spin this up. Everything should go to plan, hopefully, but I've said that before, so we'll see. Aha, so learning moment, right? I didn't configure a polar, right? I didn't configure a polar for my inbound adapter. Now, this makes sense. So remember, Spring integration is going to let us write code as though the messages will come as an event, right? The downstream components don't need to care about where these incoming messages come, right? So for example, the transform component here, this file to string generic component, has no idea where this incoming file comes from. But we know upstream, we know upstream that the message comes from this inbound adapter. The inbound adapter is going to respond to new messages, and it does this by polling the file system. That is to say, it scans the file system at a period, at an interval. So we need to configure that interval. We need to configure, how often it should do that. But not all systems have this requirement, right? Not all systems are unable to pull themselves, right? So for example, IMAP idle. IMAP idle has a way to do push notifications. You don't need to constantly interrogate it. You can just listen asynchronously and be told of when the message is there. Similarly, your message queues, for example, RabbitMQ and most JMS brokers and so on, all have a way of doing the same thing. So Spring integration has this idea of a polar for those systems that don't have this idea. So that from our perspective, we can write code as though the message will get delivered asynchronously, and it doesn't matter if the original system actually supports it, right? We'll make it work one way or another. So I'm going to say that I want to pull the directory every second, 1,000 milliseconds. And let's go ahead and restart this here. Okay, good stuff. So there's our simple integration flow. Let's go ahead and try this out. So I'm going to copy the Google logo here into the input directory. And we see that it failed utterly and completely. And the remote directory expression, aha, I forgot to specify where I want the incoming files to be written. So I'm going to call this, what did I say? What was the last directory? Uploads. Okay. Now that message, that file is still resident in the directory. So as soon as it started up again, it noticed it and it successfully created the message, and it sent the message through the processing chain. So users JLong desktop in google.jpg was created, and then finally down here in the FTP session logic, we see file has been successfully transferred to uploads google.txt.writing, and then finally it was renamed to uploads.google.txt. So here we already get some benefit. You can see that this is the Spring integration outbound FTP adapter is doing something very smart. You see, there may be further other systems, even more systems downstream that are waiting for this file, and those systems downstream may be doing the same thing. Maybe they're polling the FTP server as that's how they're staging. They're waiting for the FTP server to arrive on the FTP. They're waiting for the file to arrive on the FTP server, and then they want to process it when it's there. Well, if we're uploading a file, and that file is named as the downstream systems are expecting it to be named, then those downstream systems may observe them, they notice them or perceive them there, and just start downloading them so that they can start processing them, even though we haven't finished uploading them. So what we've done here is Spring Integration's outbound adapter uploads it using a different name. It suffixes it with .writing, and so hopefully the downstream system's mask is such that it doesn't look for a file ending with .writing, right? And then when it's finally all uploaded, we just rename it. So then it's a sort of a pseudo-atomic, or at least very, very quick, and it works. Okay, so there we go. So that worked. We actually have now an ASCII artwork file in the desktop here. So FTP WS uploads. There's our Google logo and ASCII artwork. You can't really see it here. I wonder if I can cat it. Right, cat. Here we are. There we are. There's our ASCII artwork on the console. It's a thing of beauty. I think you'll agree. Now, one thing you may be wondering is, well, how do I reuse this functionality? How do I mean, I've done all this logic. How do I encapsulate it? Maybe I want to take advantage of all the inbound file monitoring and the ASCII art transformation, but maybe I want to have two different terminuses for my resulting message. Maybe I want to send it out to an FTP server and send it as a message to a RabbitMQ broker. And so here again, Spring integration is a great fit, right? So what we're doing here is we're implicitly sending data from one component, the inbound adapter, to the transformer, to the outbound adapter, and we're not explicitly describing the flow of that message between components. It's just assumed for us. In Spring integration, we call this a chained flow, right? But we can make that conveyance explicit, and this is actually to our benefit. There's this notion of a message channel. A message channel in Spring integration refers to a named conduit. It's a pipe through which messages pass, and we can use channels to stage the output of one flow for delivery to another flow. So let's go ahead and break this apart. Let's go ahead and move the processing for the FTP to another flow, and then we'll add another flow still, so that we're going to have the original flow. It'll send a message on a channel, and then we'll have two different consumers at the end of that channel, on the other side of that channel, that will process it, right? So we're going to go ahead and now build a channel. We'll say message channel, and we're going to call this the, what are we going to call this? The file processors, I guess, or ASCII processors. That makes more sense, doesn't it? So we'll call these the ASCII processors, and we're just going to return a message channel. And again, a message channel has no implied functionality by default, right? It's just a named conduit. It's like a Java util queue in the common case, right? So I'm going to build a publish subscribe channel, and here we go. We're gonna go ahead and build it like that, and we're going to use that channel to send this data out. So instead of saying handle with adapter, I'll cut that out, and I'll say channel this.ASCII processors. So now it's being sent on the channel where we don't know, but we don't care either, right? We just know it's some other downstream component will respond to it. So now let's go ahead and reinstate the FTP flow. We're going to say FTP, and we will return an integration flow from this ASCII processors, and we'll, same basic thing here, except we're taking the data from our incoming channel. So now our code becomes a little bit more modular too, right? So we get benefits by using channels. Now we can reason and we can test out subsections of the flow, of the processing flow, without having to test everything, right? We can, in isolation, we can see that this flow for sending a message to the FTP server works. In fact, you could inject just this channel itself into your code and send a message into that channel. You don't have to have a Spring integration component, for example. So that, and if you did that, you would see the message go through the FTP logic until you got that correct, until it was working the way you expected, for example. Okay, so now I've decoupled them. Now what else can I do? I want to go ahead and send the message out to AMQP. So at this point, I've got actually two different concerns, don't I? I've got the FTP configuration, and I've got the AMQP, RabbitMQ configuration. So let's go ahead and kind of cordon these things off from each other. There we go. This is a nested configuration class. When Spring sees that, it'll evaluate just like any other configuration class. We are going to go ahead and now do the same thing for AMQP. We'll say configuration, public static class, AMQP configuration. And what are we going to do? We're going to define the middleware, the infrastructure that Spring AMQP and Spring integration need to talk to AMQP. So I need to bring in here the Spring integration AMQP dependency, and we need to define the infrastructure, the objects, the structures on the RabbitMQ broker. And I happen to have RabbitMQ running on my machine right now, so it's already on the same machine. I don't need to do anything else to it. It's running locally, and by virtue of the fact that I brought in Spring Boot Starter AMQP, I will get a connection factory that's pointing to local hosts. That's the default values. Naturally, I could go to application.properties and say Spring RabbitMQ and specify any number of these different properties to specify how to find the broker, but for our purposes, it is fine as is. I'm going to create some of the server-side infrastructure that's required. So in RabbitMQ, you have this idea of a broker, and the broker accepts messages at something called an exchange, which is sort of like a door or a gate. The exchange then does routing. It sends the message to some sort of queue. So there are different kinds of exchanges, and if you want to do pub sub, broadcast kind of public, communication, there's an exchange for that. If you want to do direct communication, there's an exchange for that. If you want to do hierarchical topics, which is a feature that you can't really get in standard JMS, for example, there's an exchange for that. Exchanges are actually used also as a way of doing federation, right? You can do replication from, active kind of replication from one node to another. And they're also how RabbitMQ supports talking to other protocols, right? If you want to send a message to RabbitMQ, you send it to an exchange, and it can then rewrite it for you and send it out over as a XMPP, for example, or something like this, right? So you have a lot of flexibility in this exchange construct. It adds the ability to do routing in the broker itself, right? Which is not something you get in the very simplistic JMS model. In JMS, it's a message goes to a destination, and then the consumer listens on the destination. There's no intermediary, so you're coupled there, right? Those things can never change. So let's go ahead and let's define the relevant bits here. So we care about the exchange, sure, right? We need a Spring AMQP exchange. Okay, so we'll use the exchange builder in Spring AMQP, and we'll use a direct exchange, and the exchange here is going to be called ASCII. Everything will be ASCII. So, okay, that'll be the name of the. We want this to be durable, don't we? Right. Okay, we'll build that. That means that the data will be the exchange will be kept. We want to send the data that comes into the exchange to a queue, right? So we'll create a queue here. We'll say we're going to use the queue builder, and we'll make this durable as well. So we'll say queue, giving it a name. This dot ASCII dot build. Okay, there's that. Binding, right? We need to build the binding here. So we're going to build the binding, and we'll say return binding builder dot bind the exchange to the queue, like so, or bind the queue, I suppose, to the exchange. Okay, with a routing key, and the routing key is the header that RabbitMQ will use to determine which queue to send the message, right? So the message is going to come into the exchange, and RabbitMQ is going to say, okay, well, how do I know where to send this? And a common pattern is to use a header, a special magic header, a well-known header called a routing key. And so that routing key in this case will be that the message has the routing key will be the expression ASCII, right? That'll be the name. So I'm using convention. I'm using engineered coincidence here so that everything lines up. And now we need to build the integration flow to support that, right? So I'm going to say in this case that when data comes in, we'll have another integration flow, AMQP, and we'll say integration flow dot from this dot ASCII processors, and we'll say handle with adapter, and we're going to do the same thing again, except this time with the AMQP, and the AMQP bit is going to need an AMQP template, right? So we'll say inject the AMQP template, which is automatically provided for us by Spring Boot, right? The auto configuration. there's this, and the exchange name, of course, will be ASCII. So I guess we should make that value. Well, even, you know what, this flow could actually be local to that configuration. That's actually another really convenient side effect of this sort of modeling is we get that. Although now, of course, the channel doesn't work. So maybe it's just better to flatten this for now. Let's just flatten this configuration namespace. And we're going to say that the data, as it comes in, will be delivered to ASCII, and the routing key will be this.ascii, okay? So there's our integration flow. When it comes in from this channel, it's going to be sent out onto the AMQP adapter, which is going to send it to that exchange using this routing key. Okay, so you know it should work as expected. It'll get delivered to the queue, and hopefully something on the other side will be able to respond to it. Okay, so let's go ahead and try this out now. If everything goes to plan, we should see the results in the RabbitMQ broker. Let's confirm by logging into RabbitMQ and clearing out whatever we've got in there already. So I've got 3 messages. Let me just go ahead and purge it right now. Okay, purge, delete even, since we want to start from 0. And we'll go ahead and restart. Seems I've already got it in the broker. I've already got this exchange and so on, so I need to delete all of it so that my configuration that I provide doesn't conflict with what's actually in practice in play, right? So queues is gone, exchanges gone. Go ahead and restart and let the new configuration override whatever I had before. Cool. So we saw that the file's still in the directory, so it's been uploaded to the server. It's replaced it, and now if we go to here, we should see ASCII. There it is, right there. There's our ASCII exchange. Let's see what's in the queue. That's where the data is actually stored, after all. And there's one message as yet processed, and so we can get the message here by saying get message. And there it is, in all of its glory, the ASCII artwork for the Google message, or Google logo rather. So there we go. We've used Spring integration, and we've staged our processing through channels. Now, this channel concept is going to be very useful later on, right? So if you're using Spring Framework itself, you can use channels to work with WebSockets, right, in Spring MVC. And if you're using Spring Cloud Stream, then the channel becomes the sort of connective tissue between messaging-based microservices. And we'll talk about this more, I hope, in further installments. But with that, thanks very much, and see you next time.